Hey everyone, welcome back to another lecture of Godzilla. As in the previous lectures, you might know that we have done the one of our sorting algorithm, which is selection sort. And today, what we will be covering up is the insertion and the bubble sort. So let's take bubble sort for today and insertion sort for the next video. So bubble sort is just similar to the selection sort, but the thing which is which make it different from the selection sort is the ideology which it follows. Because here we have to find out from the maximum. Now let's get to the video and understand from there only. So again, as from like last video, we have used this uh, like this code only to make it for the selection sort. We will be modifying this or making another function for the insertion for the bubble sort. And now let's firstly understand the intuition or the thought process or how it works specifically. So this is our previous code which we have understood. This is selection sort. So now we will be learning the bubble sort. And let me just make this bit more bigger. Yeah. So now in the bubble sort also, I have told you, it is similar to the selection sort, but the difference is it is opposite, we can say, from the bubble sort, because here uh, um, we have to think about the maximum. Here we will be finding maximum and taking it to the end. So, as in the previous one, if you have understood and gone through that video, so there you might have understood like we will be finding minimum and taking it as beginning. Now, what we will be doing is we will be taking and finding the maximum and placing it at the end. Find the max, place it at the second last. Find max, place it at third last. So this way, we will be now sorting from the last to the first. So in this swapping also happen, but the thing is here adjacent swapping happens. Swap happens, but it will be adjacent. So what do I mean by adjacent swapping? So it means like we will be swapping one by one. Like we will be finding if what is the number which is maximum from these two, swap it, swap it, swap it. So what will be happening? Let me explain it with the help of an example. Then it will be way more clear to you. Let's take 2, 3, 1, 9, 14, 4. Yeah. So this will be our like let me take one or two more things. Like if we take 7 also here and if we take 8 also here. Now it is now a bit more like an array and we have to implement a bubble sort on it. So in bubble sort, as I've told you only, what we will be doing, we will be going iterating from the beginning till the end and finding the maximum and placing it there only. We will be doing adjacent swapping in the beginning. That you have to think of. So adjacent swapping means we will be comparing these two numbers. If if the number which is I plus 1, if this pointer is I, this is I plus 1. If this number is greater, then it's okay. But if this number is smaller and this number will be greater, then in that case we will swap. Now in the first case, you will be telling me like, can we swap this? I said, no, we can't. So we will go again and we will be doing 3 and 1 comparison. So can we swap this? Here I is greater than I plus 1. So we will be swapping off. So here swap will happen. Here it will not happen. So after swap, it will become like 1, sorry, not 1. It will be 2, 1, 3. Although this is not a swap, although this is not that sorted one, but still just think about it. Uh, like we have swapped these two. Now our next number is 9. So is this satisfies the condition like I is less than I plus 1. So we didn't have to swap off. Now here comes the 14. 14 also is greater than 9. So we didn't have to swap. So it will become 14 here. Now here comes the 4. So when we encounter 4, then the situation changes. I becomes greater than I plus 1, then we have to apply swap. As soon as we swap, what will be happening is instead of this 14, we will be getting our 4 and 14 will be going here. Okay. So just think about it like 14 is the maximum element and we have to target this element only to reach it till the end. And see, our algorithm will do it. We will be just following the step and our algorithm will take it there only. So we will be having 14 here. Now next comes the 7. Again the issue happens. Again 4 have to go and it have to exchange its role like it have to be swapped with the 7. 7 comes here and 14 comes here. Again 8 came. Again the situation of swap. Again we have to like remove this. So we will be removing this and then we will be having 8 here and 14 here. So at the end what happened? What we admired of like getting our maximum element at the last, we have done that. We have successfully done that. 14 as is the maximum element and it came as the last. So first iteration this is done. Our task is done. Second iteration, now let's think about it of the second iteration. Second iteration, we have to find the second last element, second largest element, and place it at the second last position. So now let's observe it from our naked eyes only. Like 9 is the second last, and in this order also 9 is at here. So let me present the new order 7, 8, what's it? So 9 will be here, and we have to place it here in the place of 8. So now let's run it again and let's see if it was able to do it or not. First iteration, a swap happens. Yes, because one is like it satisfies the condition of swap. I is greater than I plus 1's element. 1, 2 will happen. Now 3 is here. Nothing will happen because 2 is smaller. 3 and 9, something will happen. No. So here we'll be getting 9. 9 and 4. Think about it. I is greater than I plus 1. So it will get swapped. So we have to remove our 9. We have to remove it and then we have to place 4 here and 9 will come here. And 9 and 7. 7 will be coming here. So 9 and 7 again satisfy the condition. So we have to swap the 9 again. So that 7 will be here, 9 will be here. Again we have to go till here. 8 will be coming. Again I is greater than I plus 1. So again a swap will happen. Again 8 and 9. And we will not go till then. One by one we will be reducing the values. Like in the first iteration we will be going till end. Second iteration we will not go till end. Third iteration we will be not going till second last. Third last, fourth last, and so on. In this way we will be sorting it off. Now you can see that this hole is now sorted. It is done. Like uh, thought process is done. And let I will be telling you why we use this over like selection sort, like why this is needed. It will also be having same time complexity in the worst condition, but we will be thinking how it is better in the other cases. So we will be using this only here. I have already like told you in the first video. There will be vector ARR which we will be initializing and all the stuff. So now let's start coding it off. So we will be making a selection sort. So firstly, let's understand like what this selection sort was doing. So selection sort, as I have told you only, it is basically using the minimums. Like it was finding the minimum and then swapping it off. So will be happening is what will be happening in the bubble sort is we will be finding the maximum ones and then swapping it. So now let's see how we can do that. So now let's get started. So if we have a void if we can make a void function, and it will be of bubble. And what we will be taking is this vector int and arr and int n. These are the values which we will be taking off. Now let's implement that thing which we are talking about. Int I equals to it should be starting with n minus 1, and it should be going till greater than 0 or greater than equals to 0, and then I will be minus 10. Yeah. So from here, as I have told you in the intuition only, we will be firstly taking going till the end, then we will going till second last, then we will going till third last, and so on. This will be the follow which will be helping us going in this way. Now again a for loop will be there, which will be in j, which will be starting from the beginning and going till the ith value, and then it will be j plus plus. Simple. Now we have to apply the condition of swap. If if in a case where ARR of j is greater than ARR of j plus 1, then we will be swapping them. We will be swapping j, and this is what we have to do. This is the end process. This is the ending. Like this is what we have to do here is just this thing. We have to just swap them, and algorithm will be doing. We have done it in the dry run which we have implemented. So bubble sort, place it here, and now let's run it again. See if there are any errors or something else happened, then we will be covering that. No, 5, 2 in the beginning, 3, then 9, then 16, then 1. So yeah, it gave us answer 1, 2, 3, 9, and 16. Let's take a bit more like here and there ones. Like firstly, we will be taking 5. Let's take 2 as at first, 16 at second, 35 at third, 3 at here, and 1 at here. So here also you can see that it gave us a sorted one. So I just changed it to the bubble sort, and it is now using this algorithm. Same way, the same approach you can follow, like making function outside and then let it to implement. Now let's understand the time complexity. So from here you will be thinking of like why we need this, like space complexity is constant, is big of 1 because we are not using any extra space. So the time complexity here will be big of n square, same as of our selection sort. And why we need this new algorithm if we have selection sort with the same time complexity? The thing is, we can do a optimization step here. If if at any position our element gets sorted, then we can stop this. Now let's tweak that thing so that in any of the cases it might have a bit better time complexity. So we can make a bool check which will be false, or which we can take as true instead in the beginning, and then make it as false. And after that, if there is any of the case, like if there is any case in which our check is true, then we will break the loop. Now, what the thing I'm implementing here is, if if I have to tell you, like in the intuition when we were solving this off here, at this sort of position, when we just swap the two numbers, the first number and the second number, like the array which we initialize in the beginning, there are like there are like two numbers, two maximums which we solved till now, and we get to a position where it is already sorted off. It is like 1, 2, 3, 4, 7, 8, 9. So we know, we are sure for uh, these two because we have done operations for these two only. We are sure that like these will be for sure like in a sorted way. But if the condition which I have applied, if we didn't do any of the swap, if we didn't do any of the swaps in the unsorted one, then we can say that if we are if we didn't like get a chance to swap any of the elements, means the unsorted is also in a sorted way only. So that's why we put a check if the swap which is happening here is the swap which is happening here is not like is not implementing. If the swap is not happening because there is no element I plus 1 which is like smaller than I, in that case that check will not get like converted into false, and then we will be reaching this condition of check, and then we will be breaking it off. So in this way it will be having worst type complexity will be this only, but the best will be big of n, because if element will be already in sorted way, then it will be iterating only once. Simple. And it will add a bit of optimization. That's why in instead of a like selection sort, bubble sort came into the game. So that's how the implementation of this is done. Now if we run it again, it will be like running like similarly. We can't see time complexity. Output will be same if I will give just 3, 14 and 1. That will be giving us in sorted way, but although we can't see time complexity here. So that's how the bubble sort works. So I hope you like it. Thanks for watching it.